Today on the blue team we have Euler and Pythagoras, and on the red team we have Fermat and Euclid. As always, we are joined by our two captains, Rory and Sam. The rules are simple. A player from one team reads a card and the member of the other team has to decide whether it's true or not. Guess correctly as a team and you earn a point. Most points wins. Euler, it's your turn first.
I once discovered and calculated my own number and named it E after myself.
Well, okay then, what exactly is this number?
Well, to 3 decimal places, it is 2.718.
Okay. How did you create this number?
So, Jacob Bernoulli discovered a constant when working on compound interest. I calculated this constant to 23 decimal places and took credit for it by naming this number Euler's number, E. If you take the limit, as n tends to infinity, of the function 1 plus 1 over n, all to the power of n, then the result is E.
Is that it?
I'll have you know that number is also the limit as t tends to 0 of the function 1 plus t to the power 1 over t.
Well, that's just the
I wasn't finished. My number is equal to the sum of the infinite series of 1 over n factorial, and it is the unique positive real number such that the integral of 1 over t with respect to t between the limits 1 and e is 1.
What? There is no way your number is equal to all those things.
I'll tell you one more thing. It's irrational. There are currently 116,000 known digits.
Okay, red team, what do you all think?
I say lie. 116,000 digits and there's still more? No way.
I reckon it's true.
I also think it's a lie. So, you've decided it's a lie. Euler, would you like to reveal the answer?
It is a truth.
And after the first round, the blue team are leading by 2 points to 1. Euler, would you like to read your next card?
If you raise my number to the power of a variable x and consider it a function, then not only is that equal to the infinite sum of x to the n over n factorial, but this function has many unique properties and uses in almost all areas of mathematics.
Well, what can you do there in calculus, let's say?
It is the only function such that its derivative is the same as the original function, which follows that this function is its own antiderivative too. Furthermore, if you were to take the natural logarithm of e to the power x, or let's say e to the power of the natural logarithm of x, both answers are just x.
Now, there must be a lie, but go on, I want to see where this goes. What about complex numbers?
In fact, I created my own formula using e to the power of ix and called it Euler's formula. So e to the power ix is actually equal to the complex number cos x plus I sine x. And if x were to equal pi, well then e to the I pi plus 1 is equal to 0, which I call Euler's identity after myself.
You like to name a lot of things after yourself, don't you? It seems hard to believe that you name everything after yourself. Well, let me guess, you've also found a statistics distribution that you named after yourself?
I wish, but alas, no, I do not. Although, there is a distribution in which my number e is used.
This ought to be good.
So, the Poisson distribution is popular for modelling the number of times an event occurs in an interval of time or space. The probability of k events happening in said interval is equal to e to the power of negative lambda multiplied with lambda to the power of k over k factorial. Well, lambda is the average number of events happening per interval, and e is, of course, my number.
That's rich. Anything else you fancy wasting your time with?
Well, yes. In trigonometry, you can define the hyperbolic functions in terms of e to the x and e to the minus x.
How so?
Take sine x, for example. Taking half of e to the x minus e to the minus x will give you the value of sine x, and similarly cos x is equal to half of e to the x plus e to the minus x. And from these definitions, you can define the rest of the hyperbolic functions. Since tan is just sine over cos, And koshek, shek, and kof are the inverse of shine, kosh, and than, respectively.
Okay, Red Team, it's time to guess.
I started off thinking it was complete rubbish, but after hearing how much about it in detail, I'm inclined to say it's true.
Yeah, well, I made my mind up after he said the derivative and antiderivative were the same as the original function. Lie.
Well, we thought it was lying last time and he tricked us. So I'm going to say true this time.
They're going with true. Euler, are they right?
Sadly, yes. That was all
Yeah!
true.